Good morning, everyone. Welcome back. This is review day week 2. Today is May 26, 2022. And we are going to practice multiplication between binomials and special case formulas. Okay, so I have over here some binomials and a binomial multiplying a polynomial. And down here, I have only 2 types of special cases, okay? If we have more time, then we're going to practice a little bit more of special cases. If not, then we will not be able to do so, okay? We are going to practice the formulas, okay? Formulas are really easy. That's why I'm just placing 2 right now. If there's time, then we're going to place some more, okay? At least one of each if we have the time. Remember, 35 minutes is not much time, okay? So right now we're having binomials. 17 and 18 are binomials multiplying binomials, okay? And what are we going to do? We're going to use FOIL or distributive property, okay? FOIL is just like the abbreviation of the procedure, where the first term multiplies the outer and the inner, and then the last term also multiplies the outer and the inner, okay? So in this case, that's what we're going to do. Multiply the 6k times the 5k and times the 5, and then the 5 times the 5k times the 5. Remember when we are multiplying a monomial times another monomial, we multiply the coefficients and we multiply same variable with same variable. In other words, we add the exponent if they have the same variable. If they have a different variable, then we just go ahead and copy them both. Okay, so let's multiply over here. How much is 6k times 5k?
30k.
30k?
To the second power.
To the second power, very good. Remember, we add the exponents when we have the same basis multiplying. 6k times 5?
30k.
30k. How much is 5 times 5k?
25k.
So plus 25k. And the very last one, the second term with the very last term, it's 5 times 5?
25.
So plus 25. Now, remember what I told you in class. Whenever you have a binomial multiplying another binomial and they have their corresponding terms with variables with the same exponent, meaning 6k and 5k, they're both on the same spot in the binomial, first term, and they have the same exponent, the middle terms are going to be like terms. So we're going to have as a final answer 30k squared. How much is 30k plus 25k?
It is 5k.
Plus 55k, very good. And we copy the 25, the plus 25 at the end. And that is a multiplication using FOIL or using distributive property, okay? It's basically the same thing. Questions so far? No. Easy peasy breezy, lemon squeezy. Let's do the second one. Still, same thing. First term multiplying everything on the second parenthesis, and then the second term multiplying everything on the second parenthesis, okay? So we're going to say 3x times 4x.
12x to the second power.
12x to the second power. 3x times 3.
9x.
So positive 9x. Negative 4 times 4x.
Negative 16x.
Negative 16x. And negative 4 times 3.
Negative 12.
Aha, negative 12. Are my middle terms like terms? Yes, they are. You can see they are like terms. So let's simplify that. So we're going to have 12x squared. How much is 9x minus 16x?
negative 7x.
Negative 7x. And we copy the minus 12. And that's it. That's multiplying a binomial times a binomial. Questions? No? Okay, let's go with the next one. Next one is a binomial multiplying a trinomial. Does it change our procedure? Just a little bit, because now we have 3 terms on the second parenthesis. So we need to multiply the first term times everything inside the second parenthesis, so times all the 3 terms, and then the second term of the first parenthesis times everything inside the second parenthesis. So this is not called FOIL, this is just discrete property, okay? FOIL is only between a binomial and a binomial. So we're basically doing exactly the same procedure, except that we're doing it now 3 times. So how much is 4a times 6a squared?
$24A.
24a
To the power.
to the 3rd power, because we have a square and an invisible one. So we need to add exponents. 4a times negative a.
Negative 4A.
Negative 4a
To the second
sec-
power.
to the 2nd power. Very good. And now the first term with the last term of the second parenthesis. 4a times 2.
8a.
8A.
8a. Very good. So positive 8a. Now we go the same thing, but with the second term. 2 times 6a.
12a. Second
12a.
power.
How much? I'm sorry?
12A to the
12A.
cube.
To the cube. Are you sure it's to the cube?
To the second power.
To the 2nd power, because the 2 doesn't have no variable. 2a times negative a.
Yeah, negative 2a.
Negative 2a. And the last one. 2 times 2
4.
plus 4. Now, what do we do now?
Look for the like terms.
Look for the like terms. Do I have a like term for 24a cubed? No. Do I have a like term for negative 4a squared?
Yes.
And what's the like term for that?
12A to the second power.
12a to the 2nd power. Very good. Do I have a like term for 8a?
Yes.
What is it?
Negative 2A.
Negative 2a. Very good for remembering the sign. And do I have a like term for 4? No.
No.
So I just go ahead and copy the first one because it didn't have no like term. So 24a cubed. How much is negative 4a squared plus 12a squared?
8.
Negative
Negative what?
4.
Negative 4. Are you sure? Negative 4a squared plus 12a squared is
Negative 3.
8A
very good. 8a to what power?
to the 4.
To the 2nd power. We keep the term variable, okay? The variable keeps the exponent because we're adding or subtracting. Only when we're multiplying or dividing, our exponent changes, okay? But if we're adding or subtracting, like in this case, different signs you subtract, you get the sign of the greatest number. So 12 minus 4, it is 8. We just go ahead and copy the variable as it is. Now 8a minus 2a,
6A.
positive 6a. And I copy the plus 4. Okay, because I don't need to do anything else with that one. And as you can see, none of them are like terms. Therefore, that's my final answer. Questions? No? Okay, I'm gonna leave the 20, the exercise 20 for you to do it afterwards, or maybe we can come around to it again. I just want to work now with formulas, okay? So remember, we have 7 formulas for multiplications of binomials, okay? We got, and 1, 2 of trinomials, okay? In those, we got addition of perfect square, subtraction of perfect square, difference of squares, addition of perfect cube, subtraction of perfect cube, and then the one that has a binomial and trinomial, that would be difference of cubes and sum of cubes, okay? So we have 7 formulas, okay, Kevin? We have 7 formulas. Right now, we're just gonna use formula 1 and 2, okay? So what are our formula 1 and 2? We got 3x to the 4th power minus 2 to the square. And we got 5y cubed plus y squared and that to the square. So I'm going to write over here the first 3 formulas that we have. We have perfect squares. So we got a plus b, and that is to the square. And the answer that we're going to have right now, because we're doing multiplications, is going to be a to the square plus 2 times a times b plus b to the square. Okay, this is our first formula. Now we are going to have our second formula, and it is basically the same thing. The only thing that changes is that since this is a subtraction of perfect squares, okay, we are going to have a subtraction in our first term as well. Okay, so let's continue with that. Now, the third formula that we have is the one of difference of squares, where I have exactly the same parentheses, but with a different operation. One is an addition and one is a subtraction. It is a multiplication between binomials. And this is the only case where my multiplication between binomials will continue to give me a binomial. In the other cases, it gave me a trinomial as an answer. In this case, it gives me a binomial. So this is formula 1, addition of perfect square or sum of perfect square. This is formula 2, difference of perfect square. And this is formula 3, difference of squares without the perfect. So for this exercise, what formula should I be using? Formula 1, 2, or 3?
Two.
Formula 2. Very good. So let's identify A and B in order to us use afterwards this part of the formula. Okay, so what is A and what is B? Remember, A will always be in the binomial from the sign to the left, everything on the left side. And B will be from the sign to the right, everything to the right, without taking into account the sign. Okay, why? Because my formula already has the sign incorporated. So 3x to the 4th power is going to be
A.
A. Very good. All of it is going to be A. And B is going to be only the 2 without the sign. Okay, because I already have the sign in my formula over here. So let's substitute. Instead of A, 3x to the 4th power. And that goes to the square minus the 2 of the formula times A, that is 3x to the 4th power, times B, and B is 2, plus B to the square. B to the square is 2 to the square. And now we simplify. Now remember, whenever we have more than one thing on our parentheses, like in this case, we got a variable with exponent and it has a coefficient, then we do power of a power. So we do power of a power in here. And how much is 3x to the 4th power, everything to the square? Chatham? Adam, how much is 3x to the fourth power? Everything to the square.
Six X.
Are you sure 3 to the square is 6?
9x,
9x to what power?
8,
To the 8th power. Why is it to the 8th power, Kevin? Because the rule of exponents, when we have a power of a power, says that we need to multiply the exponents. Okay, don't forget about that. Okay, now -2 times 3 or 2 times 3. I'm going to place a negative over here. How much is 2 times 3?
6.
6. And 6 times 2?
4.
6 times 2.
Negative
12.
12.
12. And we have the negative already over here. X to the 4th power. Because I copied the variable just as it is. Plus, how much is 2 to the square?
4.
So plus 4. And that's it. That's my final answer. I don't need to do anything else. Are we clear? Okay, let's do the next exercise. It has a little trick, okay? Something in it is a little bit different, and you're going to be able to identify it. So what formula should I use in this case?
The first one.
The first one, very good. I'm going to copy it already so we can have it over here, ready for us to substitute. Let's identify A and B. What is A?
5.
Only 5?
All 5y to the cube.
5y to the cube. Okay, you need to talk completely the term that is A. That's A. And B?
Y to the second power.
Y to the second power. Now, pay attention to this. Both terms have the same variable, which is y. We cannot take out a GCF in here because we have it to the square. So we cannot take out a GCF y. So we just go ahead and do our procedure normal, okay? Because we're not factoring, we're multiplying. So it doesn't matter because we are multiplying, okay? So we're gonna have A is 5y to the cube, and that will be affected by the square, plus 2 times 5y to the cube, okay? Times B, and B is y squared, plus y squared to the square, because B is y squared, so y squared to the square. We do power of a power in this case and in this case, okay? So how much is 5y cubed to the square?
25y to 6.
25y to the 6th power, because we multiplied the 3 and the 2. Now we multiply over here. 2 times 5y cubed. Two
And
times 10
y.
y cubed, and 10y cubed times y squared. I'm gonna place the 10 because, as you can see, there's no coefficient in this third part over here of the product. We multiplied already the 2 times the 5, so that's 10. But I got a y cubed times a y squared. What should I do in that case? They are the same variable, and they are
Add.
multiplying. I add the exponent. So this is going to be y to what power?
5.
To the 5th power, plus y squared to the square. Y squared to the square.
Y to the 4th power.
Y to the 4th power. Very good. And that would be my final answer because we are multiplying. That would be my final answer. If I ask you, what is the GCF of this trinomial? What would you say? What is the GCF?
Y.
Only y?
5y.
Y to the fourth power. Remember, when we take out the GCF, it will always, always, always be the variable with the smallest exponent if and only if the variable is repeated in every single term. Like in this case, it's y in the first term, y in the second term, y in the third term. So we pick the one with the smallest exponent as part of our GCF. Sometimes our GCF is just a variable alone. Sometimes it's a variable with an exponent. And sometimes that variable also has a coefficient. Okay, we clear with that? Okay, let's do one more exercise. Let's say that we have 5h to the square, k to the cube, plus 6j to the 5th power, m, and that I'm going to be multiplying it times 5h to the square, k to the cube, minus 6j to the 5th power, m. What formula should I use in this case? What formula should I use? Formula 1, 2, or 3, or 4, or 5, or 6, or 7, because you have them in your index card. So what formula should I use in there?
3.
Formula 3, very good, which is this one over here. Okay, so I'm going to identify that this is the part that I need to solve. And now I just need to identify A and B. How much is A? How much is A?
5h to the second power and k is 3.
Very good. That's A. Does it matter from what parenthesis I identify it? No, right? Because they're exactly the same terms. And what is B?
6g to the 5 power m.
Very good. This is B. And you see, I can pick both from the same parenthesis, where is the addition, or I can do it from the subtraction, or I can do one from each, and my answer will be still the same because they're the same terms, so it doesn't matter. So I'm going to have 5h to the square, k cubed, and everything to the square, minus 6j to the 5th power, m, and everything to the square. How much is 5h squared k cubed, everything to the square? Remember, we do power for power.
25h to k 3.
25, sorry?
25h to the second power. H 4 to the
H to the 4th power because we multiply. And k to what power?
plus 6 power.
To the 6th power. Very good. Minus 6j to the 5th power m, everything to the square.
30j.
30 what? Only 30?
36.
36. J to what power?
25.
To what power?
10.
To the 10th power. Because 5 times 2 is 10. And m to what power?
2.
To the 2nd power. And that is my final answer. This is a difference of squares. Okay? Questions? No? One last exercise. Okay? So we got it, x minus 1 times x squared minus x plus 1. What formula should I use in there? Because I'm telling you, prove it with the formula. So what formula should I use in there? None of
Perfect
this.
cubes.
Ah, the cubes, okay. So formula of the cubes is how? What is the formula, Camila?
Parentheses A minus B and parentheses A to the second power added by AB
Plus AB.
plus AB and plus B to the second power.
Plus B to the second power. And that will be equal to what?
A to the cube subtracted by B to the cube.
Minus B to the cube. Very good. That's the formula that you should try and use here. The first thing that we're going to do is do what? Prove the signs. Okay, they have to be exactly the same signs in this place. If they're not like that exactly, then we cannot use this formula and we should use this dirty property. So we got negative, positive, and negative. This is not positive, and positive, sorry. And this is positive, but this is not. So just because this is not positive, we go ahead and do the dirty property, okay? Now let's pretend that this is positive. Okay, let's pretend that this was all correct. So the signs are correct. Now, I identify A from the first parenthesis, and I identify B. Now I just need to prove that my second parenthesis is according to the formula, that is A squared plus AB plus B squared. So this is supposed to be A to the square. So if A is X, we have to have X to the square, and X to the square is X squared. Do I have that? Yes. Middle term is supposed to be only A times B. A is X and B is 1. X times 1 is X. Do I have X in the middle? Yes. So far, so good. And then the last one is supposed to be B to the square. B is 1, so without the sign, remember, so 1 to the square. 1 to the square is 1. Do I have 1 to the square over here? Yes. So everything is correct. Therefore, I use this side of my formula to simplify and give my final answer. So I'm going to have A cubed, which is X to the cube, minus B cubed, which is 1 to the cube. X to the cube is X cubed, minus how much is 1 to the cube? How much is 1 to the cube?
1.
1, because 1 multiplied 3 times, it's 1. 1 times 1 times 1, it is 1. And that is a perfect cube. No, sorry, that is a difference of cubes. Okay, that's a difference of cubes. Any questions? No? Okay, then. This is everything for this second day of review. See you for the next class.